All right, so here's the calendar for the week. I already said this with you guys. This is to be done along with the worksheet. I got to post that worksheet right in here that you started off class. That's one assignment. We're not double doing that because I gave you some time. And then this is the notes for tomorrow, right? What I'm doing right now. So tomorrow, those that will be here, I'll probably just leave you alone because I just saw the hands in here. Half the class is missing. All right, and I think the same's happening with second hour. Now we're going to do something this day, and then Friday we're also going to have a 3-1 to 3-4 quiz along with our 30-point Chapter 2 quiz. If I do add a video tomorrow, it'll just be a reminder of what kind of things I like on the Chapter 2 quiz that we need to do better on. So I might remind you of the types of questions. Maybe pull up the quiz itself because I'm not redoing the quiz questions for Friday. So I could look at those again. You can maybe use them as notes, write them down, note to self. This is how I have to solve. All right, so that's a big mouthful. All right, so here's what it is. Go ahead and start writing this down if you want. By the way, a logarithm is another way of writing a what? Exponent. So if exponents have rules, by golly, logarithms should have similar rules. So if you want to remind yourself of these three things, because that's exactly what's going to happen with the logarithms. They're going to have these same properties that you learned last year. We're going to delve into them more than we did last year, though, I think. That's actually not true. About the same, but it's good to see it again. So, first rule is if I have two numbers of the same base multiplied together, I add the exponents. We're going to use that same terminology for a logarithm. Two numbers of the same base divided, I subtract the exponents. And the last one is a power raised to a power, I multiply the exponents. Boom! Okay, what's a logarithm? Another way of writing a what? Exponent. So I can convolute these sentences in order to make it work for the logarithm rules that you're going to have memorized. Okay? Ooh, I just want to go one more here. I guess I'll stay right where I was at. That's good. Okay, so how's this first one? Numbers of the same base multiplied, you add the exponents, which is what I had up for that other one. Well, what's B represent? Just to answer that question, what's B? Base. What's R? What do we call that? What position did we call it? Answer. What is the answer to a log base B of our question? What's the result of this? It starts with an E. Exponent. So lo and behold, this whole expression represents an exponent. And this whole thing represents an exponent. What am I doing with those two exponents? Adding them. So look at how I get that sentence to work. Numbers of the same base multiplied together, I add the exponents. All right, maybe doing a little bit of a stretch on that, but I'd find it infinitely sad if you have a logarithm of two numbers multiplied together and you subtract two logarithms. You already know the rule from exponents. It translates to logarithms. So multiplication's related to addition. Division's related to what? Subtraction, and so on and so forth. And I'll get to that last one. So log base B of R over S, two numbers when divided of the same base, I forgot that part, you subtract the exponents. And that's what those two expressions represent. Right, and then the last one is a convoluted way of doing the power rule. This basically represents an exponent raised to a power in a way. So, what can you do with these two powers? You can multiply them. So C represents an exponent, and so does log base B of R. So ultimately you are doing the power raised to a power rule. Believe it or not. By the way, do understand the left side represents the condensed version of the logarithms, or logarithms written in terms of one log. The other side represents the expanded version of the same thing. One logarithm written as two or more logarithms if possible. Except for the last one, that's just pulling out the exponent out in front. Okay, so do you understand expanded compared to condensed? All right, we'll just proceed on. What we're going to do is prove one of these logarithms. Now, I'm basically doing what the book does, but I want to write it with you and see how they do this little production. And I believe I've assigned where you have to prove one or both of the other ones. You're going to use this logic, if you want to call it that. So follow along what I do with this, and if one of the questions says prove the subtraction rule or prove the power raised to a power rule, if you want to call it that, this is what you do. First thing you do is let x equal log base b of r. Just do it. So let that equal some variable. And then the other logarithm, let that equal some other variable. Oh, perhaps like y. What's LO6? Now, the first bridge between a logarithm and an exponent is doing changing the log to an exponent. So change each one of these to an exponent. How does that happen? What's the base, everybody? Come on, answer the question. B. What's the exponent, everybody? X. And what's the answer? So now we're going to turn that logarithm to an exponent and do some exponent stuff. So then this one obviously becomes b to the y equals s. Now I guess I can kind of try to explain this, why they do what's happening next. We're going to do a product, because this is the product rule. You can see what happens. So basically what I'm going to do is take these two and multiply them. Now, what does that equal? Well, what does r equal, everybody? B to the x. What does s equal, everybody? So this would be an equal statement based off of how I started this whole shindig off. And now this is the key. We know exponentially what we do with this. What's b to the x times b to the y equal to? B to the x plus y. And then you know what you're going to done do after this? This is a what kind of scenario? This is a what kind of scenario with three positions? This is an exponential, and now what I'm going to do is reverse it and turn it into a what? Log. We only have two more steps after this. Log base what? Log base what? B of who? RS equals x plus y. Now what are we going to do? We're going to look up here and see what x is. What is x the same thing as? What is y same thing as? So I kind of wrote a little bit large. Log base b of r times s does in fact, through resubstitution, equal log base b of r plus log base b of s. And that's the proof. Remember what a proof is all about. All your steps in the middle, not the end. Of course, that's what we wanted to get. But here's the bridge right here. This is the most important thing. Right in that middle. B to the x times b to the y. We use that exponential rule that we know, and then it turns into a logarithm rule by changing it back to a log. So this is redonkulously easy. This is a bunch of long-worded explanation for just the word expand these logarithms. So, what's this first one become? ln what? Then what? Plus what? ln y. That's it. And I feel like doing much more than this. What else could we possibly do? What's the next one? Log what? 10 what? Minus what? Log y. And then you'll be marked wrong on a multiple choice. This will not be the answer listed on a multiple choice. What? Does anyone know what else we could do with this one? It's special compared to number 2. I'll let you think about that. Chew on that one for a little bit. Like lunch. Huh? What? How did you get that? Yes. Log base boo of 10 equals 1. This one's stupid. But I know what you might want to do. What's x to the negative second the same thing as? What's x to the negative second? 1 over x squared. And then what's this? What do I do now? Log base 2 of 1 minus log base 2 of x squared, which is a 2 pulled out in front. But hey, what's log base 2 of 1 anyway? 0. What's 0 minus 2 log base 2 of x? Basically, that was all unnecessary. That's the answer. So even if you did do the 1 over x squared, you would have got 0 minus 2 log base 2 of x. So all that was useless. You're welcome.
Thanks.
Did we lose the sound? I just didn't feel like talking. Now it's time to go backwards. So I'll speed it up. I can sense the boredom. What's the first answer? I should bounce around the room, but I'm not going to. Let's be efficient on the notes. Log what? Log what? Not x5. We don't write it like that, right? What's the next one? ln x over y. Oh, I get people. This is the most convoluted thing that people do. Is that the same as this? Is that the same as this? No. It's not a rule. Try to write that rule. Sell a math book. No one will buy it. Log. Okay, I bet you can do this real fast. Who goes up in the numerator? Y to the 4th over z. Please don't try to do this one so fast. Do a couple things at first. Like, what do we do with this 3? What do we do? Bring it up here and distribute it. What do we do with that? Bring it up here and distribute it. So at least give it a second. ln of x to the what? So it's just exponent rules, and then y to the what? And then plus ln of what? Y squared, and then what? Z to the 4th. And then the final answer you could write. ln of, multiply them as x to the 9th, no friends. What's y become? Y to the 5th, and then z to the 4th. So just using these rules that are true back and forth so that you can use them to solve complicated equations later. All right, now, how many people have a TI-83 or an unupgraded TI-84? Unupgraded. There's more than that. I thought there was, you don't know if you're upgraded or not. Try this real quick, and then you'll find out if you're unupgraded. All right? And then this is why, and it's not really why, but back in the day when I first started teaching, up till about, I don't know, 10 years ago or so, maybe 8, nobody had the buttons that I'm going to show you right now. Nobody. Except maybe for a fancy scientific calculator. I hit alpha, y equals, this menu comes up. How many people had that menu come up? Or I should say, how many people did not have that menu come up? Then you're unupgraded. Okay? So, the one that you need is the second one. Number 5, I shouldn't even show you this button, but it's the log base button. It allows us to type a logarithm as it looks. Okay, and if you don't have that option, you have to do the next thing. But everybody in this room will have to learn and know the change of base formula, whether you have this convoluted button or not. Okay, but what would the answer to, why is the answer log base 4 of 7 close to 1.4? Well, answer that with a question. What's 4 to the first? Answer that. 4. What's 4 to the second? 16. So the exponent has to be between 1 and 4. Isn't that right, Chief? He just shook his head. I don't know if you could hear the wind with his head shaking online. All right, so we type log base 4 of 7 and press enter. That's the cheating way. I don't like that button. You have to know the change of base formula because it does have some applications. And that's all I'm going to say about that. So, would that be the same as log 7 close divided by log 4? Did you hear me close? Did you hear that? So, what this formula is, though, change of base formula, they do call it that, is if I have log base b of x, how to evaluate that? Notice this. Log base a of x over log base a of b. All that means is the logarithm that you use to evaluate through the change of base must have the same base. What's the base on the log that I typed in here? What's this base? What is that? Base 10. Press enter. Same answer as that cheating button. Or ln 7. Close ln 4. Look at that. All three give me the same answer. Cheating button, change of base used with two different logarithms. You need to know this. Okay? So, and we knew that answer should have been what it is. There's the ghost. So I don't want to bore you, but what's the answer going to be between number 24? What's the answer should it be? What should it be? Between 1 and 2, because 5 to the first is 5, 5 to the second is 25. What's the answer supposed to be between a number 26? 2 and 3 would be a good guess. Oh, I love the next one. Somebody got it in my other hour. What should 28's answer be between? Let that sit out there, let you chew on that like lunch first. Boom, student number. This whole group thing ruined the student numbers. I'm not the same teacher anymore. Log 29. Is it better? I don't know. Was it ever good? Who knows? Negative 2.09. And then this is just, I hate these questions. Hate them, but I did assign them. So be aware of it. And it makes those that have that cheating button do this. How do I take this log base 7 of x and turn it into the natural? By the way, what's the natural log look like? ln. How many times people say natural log is log? Okay, what's log called? The common log. So how do I change this to be the natural log? The change of base. It's just a dumb way of getting you to make you use this. Yeah, it's silly. I do like this, though. Hey, I have a question. Can I do more with this one? Is ln of c minus d the same thing as ln c minus ln d? True or false? That's a false, because all I have to ask you is what does that equal to? What's ln of c minus ln of d equal to? ln of c over d. So this is false. So why did I go over that? Because students do that all the time. That is unsimplifiable. ln of c minus d as an expression, there's nothing more you can do with that, logarithmically speaking. Not true. You don't distribute the ln if that's what you're thinking about doing. All right, and then this last one is just dumb way of trying to get you to use the change of base using log instead of ln. Because that is the common logarithm. So using that terminology, knowing that. I'm done except for this. True or false? True or false, number 1? True or false, number 2? Oh! Okay, so what would that have to be true? Oh, you went to 3? Ah, dude, you got to look at your numbers. All right? This would be, what would this be? Make it true. Log base 3 of, now you got to clean it up. What would this turn into? Log base 3, 7, and then what rule would I have to use? So you're saying this is wrong. So what would be true is what I'm making you right.
So it would be log base 3 of 7 plus log base 3x.
And that's not what it is. Or this one would be, someone else said it, the exponent rule in reverse, but they're not true the way they are. Is everyone okay? All right, student, the last one, true or false? That is the actual rule. Good. So new students, true or false? Go in the same order. True. True or false? This is the one that is convoluted all the time. I already mentioned it once in the notes. I have students try to convince me that rule all the time, or at least it's written in their paper so much. All right, true or false? True. All right, then let's do everybody here. Ooh, true or false? Raise your hand if you think it's true. Raise it. Are you just not raising your hand because you don't want to raise it? You know what would be true? I'm going to blow your mind if I put a plus in between there. You know why? This would turn to a 2 out in front. What's 2 of something? The same thing as adding it to itself. So I could have blew your mind and put a plus there, and you're like, nope, that's not true. And I tricked you because that's the kind of guy I am. True or false on the last one? This is taking too long. I think they're dead. True.